Okay, today we are working on 4.7. We're going to do natural logarithmic functions, and then the next lesson we're talking about trig functions involved with logarithmic functions. So your homework is going to be 1 through, 1 through 12, I believe. And so I'm going to do number 1 and number 10, so really easy one and then a more difficult one. So we'll start with number 1 from the homework. So we are integrating 1 over x plus 1, that's dx. And remember that integration is just an antiderivative, so if you remember what ln of x, if we're deriving this, we're going to get 1 over x times dx. So what we want to do here is we want to choose a u and then find the du and substitute the u in for a function. So if you look here, we probably want to sub x plus 1 in or out for u. So we're going to do u equals x plus 1, which means du will just equal dx. We come back over here, integrate 1 over u du. Know that this is going to be ln of u. And since this is just dx, we have dx here, so we know that we are basically done. Ln x plus 1 plus c. So that one's pretty straightforward, mainly because our du is written here, right? So we don't have to manipulate it or anything to try and find the antiderivative of du. So that's how you do number 1. Now I will show you guys how to do number 10, which is a little more tricky because we have to manipulate a little bit more. So number 10, we have integration of x plus 3 over x squared plus 6x plus 7. So this one is a little more tricky because we could try and do u sub u out for this one. That's not going to work super well, so we have to manipulate a little bit. So we're going to do integration of x plus 3. If you look at this, this is pretty close to x plus 3 squared, right? X plus 3 squared would be x squared plus 6x plus 9. We have x squared plus 6x plus 7. So what we can do is we can rewrite this as x squared plus 6x plus 9 minus 2. These are the same thing. I just manipulated it a little bit more so that we would have x plus 3 squared. So again, I'm going to rewrite this. X plus 3 over x plus 3 squared minus 2. Now I have a u. Actually, we can get rid of this. Sorry, no we can't. Let's try that. Let's try this. 1 over x plus 3 minus x plus 3 over negative 2. Then we'll write this as 1 over x plus 3 minus the integration of x plus 3 over 2. I don't know why I wrote a negative 2 there. That should be positive. Okay, so here I can start subbing stuff in. So we're going to take this one over here. I'm going to have u equal x plus 3. Sorry, this should have a dx. This should also have a dx. dx, 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 dx. Okay, So my derivative of this will equal just dx, right? Derivative of this is going to go to 1, this is going to go to 0, and we need to slap a dx on there. So I can rewrite this as 1 over u du, which when we integrate it is just ln of u, ln of u plus c, like in the last one. Now we're integrating this one. This one is, let's think. So we can pull out half, right? X plus 3 dx. And so now we are going to x 1 plus 1 over 1 plus 1 plus 3x plus c. So our final answer is going to be ln of x plus 3 minus 1/2 will distribute, so 4 plus 3x over 2 plus c. Let me check to make sure that this is correct. X squared plus 6x plus 7. We went wrong somewhere. Where did we go wrong? Okay, so we could do it that way, I guess. So this was a trial. We didn't quite get the right answer, so we're gonna come back up here and we're gonna sub in u squared minus 2 du. So du in this, yep, okay, that's fine. Let's look. That kind of looks like it might be, oh. Okay, so u, if we look, u squared minus 2, the derivative of that is going to be 2u, right? So if we divide like that, we're going to be in business here. So ln, pulling out 1/2, right? And then we need to u over u squared minus 2 du. And so this is just going to be 1/2 ln of u squared minus 2 plus c. And so 1/2 ln of, what do we got here? X squared plus 6x plus 9 minus 2 plus c. Don't forget the plus c. So 1/2 ln of x squared plus 6x plus 7 plus c on the outskirts here. So this is our final answer right here. Sorry about this. So as you can see, if you look at your guidelines for integration, one of the steps is basically just use trial and error. So we tried going this route, it didn't work, so I'm just gonna scratch off this. So then we went a different route, and this one ended up working for us. So you'll need to use some trial and error, but I think you guys will be all right. Remember to use the back of the book to check your answers. And if you have any questions on stuff, just message me.